Hello students. Today we will discuss in this lecture another application of derivative, can be called the mechanical interpretation of derivative in mechanics, to find the velocity and acceleration using derivatives. So we start with this. Now we assume there is a fixed point O and a particle starts moving from this point. Now it reaches the point P after an interval of time T, and it reaches the point Q after an interval of T plus delta T, and this is measured from this point O. Both are measured from the point O. And also it is assumed that this distance OP is S and the distance OQ is S plus delta S. Means the particle moves a distance S in time T and the particle moves a distance S plus delta S in time T plus delta T. Then the particle travel the distance PQ, that is delta S, in time delta T. Now if we consider the ratio delta S by delta T, that is the distance traveled by the particle in time delta T, that is delta S by delta T is the average time rate of displacement, and we call it the average velocity. Now if we go to the limiting process, that is if we make delta T tends to 0, the limiting value of this average velocity is known as the velocity of the particle at time T, and we can use this limiting process to find the velocity at the point P of the particle, and that is given by limit delta T tends to 0 delta S by delta T, which we denote from the point of view of calculus as ds by dt. So that is why in physics you have seen that you have found out the velocity v by using the expression ds by dt, which we call the rate of change of displacement. So actually that comes from this concept, that is we are actually finding the delta S by delta T, that is the distance traveled by the time, and then we are proceeding to the limit as this delta T is very small, that is delta T tends to 0, and that gives us the instantaneous velocity at the point P. Similarly, we can define the acceleration also, because we know that the acceleration is the rate of change of velocity. So just by following the same process, we can say that the acceleration A of a particle can be identified with the derivative dv dt, which in the limiting process can be identified with delta v by delta t, limit of that as delta t tends to 0. So we have to use these two formulas. One is ds dt for finding out the velocity, and one is dv dt for finding out the acceleration in the problems that we are going to discuss. Now before we discuss those problems, there are some important points. First of all, just we have noted the points here. First of all, if a particle moves in the direction of s increasing, means s is the displacement function, you know. So when a particle moves in the direction of s increasing, then we should have a positive velocity, that is ds by dt should be greater than 0, and so in that case v will be greater than 0. And if on the other hand the particle moves in the direction of s decreasing, that means when ds by dt is less than 0, so in that case we have the velocity v will be less than 0. Now when our a means this dv dt, that is acceleration, when this a is 0, then we say that the particle is moving with a constant velocity, or sometimes it is moving a uniform velocity. Also when this acceleration a is less than 0, that is dv dt is less than 0, then we say that the particle is retarding, that is the particle have a retardation. If v and a have the same sign, v is velocity and a is acceleration, if they have the same sign, then the speed of the particle is increasing, and if v and a have the opposite sign, then the speed of the particle is decreasing. So these are the points which we also require when we solve problems on velocity and acceleration using this idea of derivative. Now we go to the first problem. Now if the distance traveled by a particle along a straight line is given by the displacement function s is equal to 2t cube minus 9t square plus 12t, find the displacement of the particle when its velocity is 0. So here actually some s is required, displacement, and when the velocity is 0. So first of all, from the given displacement function s, we find out the velocity function, that is ds by dt. So we differentiate this expression for x with respect to time t. So that gives us ds dt, value of ds dt as 6t square minus 18t plus 12. Now it is given, now it is, you are required to find out the displacement when the velocity is 0. So this velocity, that is v, should be, you have to equate this velocity with 0. So we make this v 0, and then from this equation we are getting two values of t. One is t is equal to 1, another is t is equal to 2. Then for t is equal to 1, we find out the displacement from the given displacement function s is equal to 2t cube minus 9t square plus 12. So from this you are getting the value of, for t is equal to 1, you are getting the value of s equal to 5. So when in this case the velocity is 0 and the displacement is 5, and again we see that v is 0 for another t, that is t is equal to 2, and at t is equal to 2 we are getting the displacement s is to be equal to 4. So we have two answers, one is s is equal to 5 and another is s is equal to 4, the two displacements were when the velocity of the particle is 0. The next problem, if a particle is moving in a straight line such that t, that is the time, is actually given as a function of displacement s, as square plus bs plus c, so that the particle undergoes a retardation which at any instant is proportional to the cube of velocity. So here you see that the function is given as a function t as a function of displacement s, t is equal to as square plus bs plus c. So from this equation actually we have to find that the particle is retarding, and this retardation, we have to find a relation between this retardation and the velocity. So for that, first of all we have to find out the velocity. So that is why we differentiate this equation, given equation of t is equal to as square plus bs plus c with respect to t itself, and that gives us the value of ds dt, which is the velocity, you know. So that is given by 1 by 2as plus b. Then again we again differentiate this equation again, that is ds dt is 1 by 2as plus b. We are differentiating it again with respect to time, so that gives us d2s dt square, which we know that actually equal to dv dt, and which we know can be identified with the acceleration function here. So d2s dt square, after some simplification like this, you are getting it to be equal to minus 2a into ds dt whole cube. So in fact we have actually expressed it in terms of this ds dt whole cube, because we have to show that the particle undergoes a retardation which is proportional to the cube of velocity, and we know that ds dt actually gives you the velocity function. So from the expression of d2s dt square, what we have got, that we have ultimately expressed in terms of ds dt. So that ultimately comes as minus 2a into ds dt whole cube, that we can write as minus 2a into v cube. So the first thing that we are getting is that d2s dt square, which is actually the concept of acceleration, which gives us the acceleration of the particle, that is minus of 2a v cube. So we know that we have just seen in the previous thing, that when the acceleration is less than 0, then the particle is said to have retardation. So here what we are seeing here, you see that d2s dt square is negative, so actually it is retarding, first of all. And secondly, we have seen that the expression for d2s dt square is actually minus 2a into v cube, where v is the velocity. So that the retardation in this case is proportional to the cube of velocity. Thus the particle undergoes a retardation, first point that we have obtained, because we have got the acceleration is less than 0. And secondly, that this retardation is actually proportional to the cube of velocity, because d2s dt square is minus 2a into v cube, where v is the velocity. Okay. Next problem, a bullet fired into a block of wood penetrates according to the law s is equal to 18t minus t cube by 6. How far does it penetrate? অর্থাৎ একটা গুলি ছোড়া হয়েছে একটা কাঠের ব্লকের মধ্যে, এবং সেখানে গুলিটা যে মুভ করছে তার ইকুয়েশন অফ মোশনটা, মানে অ্যাকচুয়ালি তার ডিসপ্লেসমেন্ট ইকুয়েশনটা হচ্ছে s is equal to 18t minus t cube by 6. নাও কত দূর পর্যন্ত যাবে, অর্থাৎ বুলেটটা কত দূর পর্যন্ত যাবে সেটা বার করা মানে হচ্ছে বুলেটটা যেখানে গিয়ে থেমে যাবে সেখানে গিয়ে বুলেটের ভেলোসিটিটা 0 হয়ে যাবে। তার মানে কত দূর পর্যন্ত যাবে সেটা বার করতে গেলে আমাদের বার করতে হবে কখন বুলেটের ভেলোসিটিটা 0 হবে। So here our s is 18t minus t cube by 6. So from that, by differentiating with respect to time, we can find ds dt, which is 18 minus t square by 2. and we know that this ds dt gives you the velocity, so you make this ds dt equal to 0 to get the velocity, to know where the velocity is 0, that is the bullet will stop when the velocity is 0. So that gives us 18 minus t square by 2 is equal to 0, where which gives t is equal to 6. So now when t is equal to 6, what is s? S is given as 18t minus t cube by 6. So it is for t is equal to 6, s is given by 72. So the bullet penetrates through 72 centimeters. Actually here we have written centimeter. Okay, so the bullet will stop after moving 72 centimeters. Now if the law of motion is s is equal to sine 3t minus 4 by 7 into cos 70, then find the initial velocity. It's another type of problem where we are going to find the initial velocity. Initial velocity means the velocity at the beginning. So your s is given by sine 3t minus 4 by 7 into cos 70. So from this you can find out the velocity expression for velocity, that is ds dt, that is 3 cos 3t plus 4 sine 70. Now to get the initial velocity, we know the initial velocity is velocity at the beginning, that means ds dt at t is equal to 0. So expression for ds dt you have obtained 3 cos 3t plus 4 sine 70. So in this expression you have to put t is equal to 0. So that you are getting, from that you are getting it is actually equal to 3. So you are getting the initial velocity, that is ds dt at t is equal to 0 is given by 3. So so these are some problems, just very simple problems where we can explain that how we can use derivative, the concept of derivative, to find out the velocity and acceleration. That means an application of derivative in mechanics, actually can call it. And that's all. So thank you.